Okay, hi guys. In today's video, we're going to learn how to integrate the basic, I would say the half tough function such as ln, exponential, sine, and cosine. Okay, so I'm just going to share you with this basic thing because usual integration, assuming I have, let's say I have a gradient function dy over dx equals to, for an example, 3x squared plus 4x. If I want to integrate this function, that becomes 3x cubed over 3 plus 4x squared over 2 plus c. You know how to do this, I know, okay? It's easy, but usually students get confused with this kind of function. So I'm just going to share with you how actually we do integrate ln, exponential, sine, and so on and forth, okay? So how you actually integrate, okay? So let me share with you something. Assuming I show you the few example. So let's say I have y equals to 1 over 2x plus 3, okay? If I want to integrate this, okay, how we integrate, this will become ln 2x plus 3, meaning anything as long 1 over, when you integrate, it will become ln. Another one example you can see, let's say I have integrate 3 over 2x plus 3. So when I want to integrate this, there's a constant, right? You must shift the constant outside. So it becomes 3 and then 1 over 2x plus 3. So now you can integrate, so 3 ln 2x plus 3. So take note, when you want to integrate, you must make sure it become 1 over some function that will become ln directly. That's how you convert any 1 over to become ln. So if you've got number, of course you do. But what if you have like this 2x plus 3 over 3x plus 3? Of course this you cannot extract. We have another way to do that. But remember, anything 1 over, you can straight convert to ln. The next question you ask me, how do I integrate ln x then? Okay, it's quite a good question. How actually I integrate ln? Integration of ln, to be honest, is not in your syllabus at this point of time. So you will never learn how to differentiate ln x for now. So that is the sad thing about ln lah. Okay, so never mind. I will just cover the next one, which is exponential function. So how do we integrate an exponential function actually? Give me a moment, yeah. Okay, so integral of let me open my slide. Okay, so to integrate exponential function also, you see, we have learned how to differentiate an exponential function. For an example, if I have, never mind, I think I'll just continue. Okay, so let's say I have this function. I have a gradient function of e2x and I want to integrate this. Okay, so the method to integrate this will be very simple. Whatever here you differentiate, okay, whatever the power you differentiate become 1 over 2 and then you copy paste. That's it. Okay, you copy paste and done. So let's say I have another function, a gradient function dy over dx equals to exponential 2x squared, and I want to integrate this. So when I integrate this, it will become, I differentiate the power. Remember, when we want to integrate exponential, we differentiate the power. So I differentiate 2x squared, I'll get 1 over what we call that 4x, and then you copy paste back. As simple as that. So remember, maybe I can summarize for you. When you want to integrate any exponential function, the power here you differentiate, and then you put 1 over differential of the power, copy paste. Okay, I show you one more example. Let's say I have e2x plus 2 and I want to integrate this. So when I want to integrate this, first I differentiate this. So I differentiate 2x plus 2, I'll get 1 over 2, then exponential 2x plus 2. That is how simple we integrate exponential function. But take no integration of what we call that ln, is not your syllabus. Next one, integrate sine x and integrate cos x. Okay, this one is a very interesting what we call that function, because I'll share with you why it's interesting. Give me a moment, yeah. Okay, so there's a way actually how we do this, okay, but I'll just share with you. When you integrate sine, you will get negative cos x, but when you integrate cos, you will get sine. Take note of that. Okay, I repeat one more time. When you integrate sine, you will get negative cos, but when you integrate cos, you will just get a sine. There's a long explanation on that, how they actually work and so and forth lah, okay, but I can't cover that now because it's not in your syllabus. But the important thing you need to know, when I integrate sine, I get negative cos, and when I when I integrate sine, I get negative cos. When I integrate what we call that, cos, I get sine. Okay, I think that's all for today's video. Thank you and bye.